well in some other set of data, so that needs to be taken care of. So, my final word, machine learning unlocks new possibilities. We couldn't do autonomous cars, we couldn't do energy mismatch, we couldn't do these fancy, crazy, non-dimensional, highly nonlinear problems, which we can address now. That is the exciting part in machine learning. Not so exciting part is that we can address some traditional control problems which we have been struggling with, but that's very little of the excitement. So, to conclude, I gave a trial lecture on model-free versus model-based control, where machine learning takeover. These are my ideas, and I'm open to some questions on that. But one thing for sure is that either this way or that way, you need some understanding of the system and how your inputs affect the outputs, which is modeling. To know a little bit more on that, you can join for my PhD defense, which deals a lot about modeling, as well as a little bit of optimal operation of separation process in oil and gas industry, which starts at 1:15.
Thank you, Tamal. That was a very interesting lecture. Normally, you don't have to answer questions, but I do believe I heard you say that you would be open to questions. So, let's break the rules here. And the machines have to learn that. We do that sometimes. So, would anybody like to ask Tamal a question?
So will machine learning take over, yes or no?
It will take over in, well, it's not even a takeover. We can't even address some problems with conventional control. So it's a niche that machine learning has created for itself in areas that we couldn't do otherwise.
So your conclusion is that no, it won't take over. But for a small fraction of problems, it could be very useful.
It could be very useful, and the thing is that in engineering we don't try to take a system that is already working and replace it with something for half a kroner extra benefit. If there is the benefit, as the benefit is very high compared to the cost, then probably yes. So some model-based control approaches where, like refining, I gave some examples, where you have to relearn the model, you have to maintain the MPC all the time. There may be model-free machine learning control can help. Yes.
Yes, Guru.
So, if the machines learn the wrong things, what do you think about that? Is there some kind of things that can stop the learning going in the wrong direction, or
Machine prison.
that you have some kind of ethical reflection about machine learning?
In the development, especially in games like AlphaGo, in the game of Go, you have a set of, it's like chess, you have a set of movements that you do over a period of time, and that leads to you winning the game or losing the game. But you might see that if I do my first move, I am doing something good, but the subsequent moves are bad, and it leads you to lose the game overall. And these things have been addressed, especially in the game framework. They have some additional aspects. I didn't go so much deep into it, but they have taken care of those things. So it will be a bit of a customized solution for every application, which through their experience working with these games and so on, they will probably be able to contribute.
Yeah, so you have to kind of define what is good and bad.
Yes.
For,
Which will be different in each application.
Now you mentioned something very important, and I'll say right up front, I'm a skeptic to all this machine learning business. And you made a very important point. You said that games, which are kind of the performance of the machines in the games, are sort of used as a selling point to say, look at what the machines can do. However, you made the point that games are set on a very limited set of moves you can make with essentially a set of two distinct outcomes, win or lose, right? So that is very, very actually simple. You know, you might not even have to make a machine learning algorithm. You could probably make just a statistical algorithm that machines could beat humans. Now, one thing that is very important is there's also no disturbances in games. So And then we saw this very illuminating picture of how machines recognize various things. And it can, with 90% accuracy, or something like that, recognize a person. Do you think this is good? I mean, this is a very poor accuracy compared to humans, right? We can do this with 100% accuracy usually. So what type of improvements would need to be made before these things can really deliver on what they're promised?
One thing data-driven methods are prone to is they are thirsty for data. The more you supply the data, the better it becomes. And there has been a lot of development, especially in the computer vision domain. And in 2012, there was it was a very tedious process. Let's say you want to have a huge database of pictures with labels. That's a tedious process, and many people develop their own network. There is a very popular network called AlexNet, which has millions of, I don't know, millions or thousands or whatever, pictures with labels. And this became a threshold breaking point where it supplied these machine learning algorithms with a huge data. And then they are probably not 95 or 90, they are maybe 98, maybe 99% sure that it's a human.
Mm-hmm.
So it's a data thirsty thing, because that's where you extract the information from.
Very interesting, very interesting. Any other questions? Wadi Tamala's done a good job. Let's give him another hand. And so now we will take a break. I suggest you all go have some lunch, and then we will meet back here.